tonight we're looking at fossils with Matthew, and then I'm going to look at time, a little bit about time, carbon dating, radio isotope dating, and just some of the way it works, some of the problems with it, and just look at different time things, just how colossal these times are that they're postulating that it is in creation. So we'll look at that later. Anyway, we'll just fire off. And that's it. So it's fairly short talk, hopefully not more than half an hour, and then at least half an hour of questions, so we'll get interaction from that. So again, the speakers probably know an awful lot more than they're saying. They're just condensing it, trying to make it get a few bullet points, and there's lots of other things we can raise.
Yeah, so my passion, one of my passions, I do quite like to sort of delve in lots of different things, but fossils is one of my passions, which started when I found this fossil, which is an ammonite, when I was probably about between 8 and 10, on the Whitby coast when we were on holiday in Whitby. And I always like collecting things, so fossil collection, rock collection is what I had when I was younger.
He's a proper hunter.
Scavenger.
Seeking and hunting.
Yeah, exactly. So for me, the thing that's most convincing about creation, in terms of what the Earth is saying, is the Earth shows that there was a massive flood through the fossils and through the geology. And that, like I say, that's always been an interest of mine. I was going to just do a quick run through of like a sort of flood model, which we touched on last week, and James touched on a bit more with how the water could have been across the whole Earth and across all the land. So just a quick run through of that, because obviously I believe that flood is what created all of these fossils and this deposition of sediment all over the Earth. So basically, really quick run through is the crust fractures somehow. God makes it fracture. The fountains of the deep break open, which it says in the Bible, and magma comes into the ocean, which is like 1,000 degrees magma. So that's vaporizing water into the atmosphere. So that could be then, that's where some of the rain comes from, is vaporized water out of the sea, which falls on the land, and it's extremely violent. There's volcanoes, could also be earthquakes and volcanoes happening all this time. Fast movement of continents, so the whole Earth's crust breaking up and moving during the flood as this water inundates the land. So as you can imagine, it's like a soup. Everything becomes like a soup. All of the land animals and all of the trees and everything, all the plants that are on the earth when God created it, all gets ripped off and moved about by water. So this can explain also the deposition of oil, like under sedimentary rocks, which is the algae in the sea gets trapped under layers of rock and creates oil. Coal as well, with logs and plant material ripped off the land and put underneath layers of sediment by this violent, flood. And these layers are undisturbed. They're flat. They don't have roots penetrating through the layers. So it shows a fast deposition rather than a very slow millions and billions of years of a slow build-up of like a peat bog or a mangrove swamp. You'd have huge amount of roots if it was a mangrove swamp, but this is very fast, very clean lines. I should have probably had a picture of that, but coal seams are very clean. Coal, and then like maybe sediment, shale, coal again. So it's interesting how it just is very unexplainable to do it slowly, really. So moving on to the fossils that you find, 95% of all fossils are marine invertebrates, shellfish, things out of the sea. So nearly everything you find is from the sea. Then there's quite a lot of algae and plants. And then you're getting down to a really small amount, 0.23% of terrestrial and aquatic insects and other invertebrates, so that's things without a backbone. And then vertebrate fossils are only 0.0125%. So extremely low numbers of like actual vertebrate fossils, like a T-Rex or like that ichthyosaur vertebrae there. So that's a reptile.
From Whitby.
That's another thing I found, which is my best find ever so far. there's lots more fossils we can look at later. So, where am I here? Yeah, so basically fossilization, I want you to see, is a process. It's not necessarily needing long time. So a process that happens in a specialized set of circumstances, the process can create fossils quite quickly, and doesn't need millions and billions of years. And actually, again, the old picture that you had in your textbook was an animal dies, it lies down, it rots a bit, then a flood, like a small local flood, comes and covers it up, and then another, like over millions of years, that gets sedimentation on top of that, creates a fossil. But in reality, you can't do that, because if a cow dies on the farm, and if it was covered by a localized flood, it would just rot away. There's no way of getting enough volume of sediment on top of that animal to fossilize it. So one really big, so this is the traditional geological column, which shows all of the different millions of years from 2.5 billion here. 500 million is where there was an explosion of life. I'll talk about that later. And it goes all the way through to sort of now. And there's a change in creatures as you go. But this is what the flood model shows, is that on its side, the flood inundated these things one by one, sort of thing. So it's taking an ecosystem and burying it, taking an ecosystem and burying it. So the Cambrian, which is your like trilobites, which were buried first because they were at the bottom of the ocean, and they're all ocean creatures. And you get ocean, 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 then you get some fish, then you get some plants, and then you get some dinosaurs which could run away and potentially, and also there's a lot less of them, so they could, hide and run and swim away for as long as possible until they get buried. And you get all the way up to into mammals at the top.
They also float when they're newly dead.
That's a good point, yeah. So animals float when they're dead often, so that they'll rise to the surface, and it's harder for them to get buried. That's just a little thing. So moving on to polystrate fossils, which is fossils which go through many layers. So they're polystrata, so many layers. And there's quite a lot of trees like this within coal seams sometimes as well. But this is going through supposedly millions of years of sediment. But this is a tree that's been ripped off. You can see a bit of root here, but it's not like that's not a growing tree. That's a tree that's been ripped and deposited, and it shows these trees are quite common actually.
There's one just off the Island Mole. It's a really good one of these.
Yeah, there's one. These are in Scotland. They're all over. I mean,
so the sediment, each one of these lines in the sediment is classed as a year or a flood event. So that tree
traditionally
stood standing up for
like
thousands of years.
Yeah.
Potentially a million years.
Yeah.
It stood unrotted while other sediment built up around it.
If you say this is like
it's not possible.
180 million years, and this is 160 million years, so that could be 20 million years of sediment, and it's maybe not quite as extreme as that, but it's still like impossible for a tree to stay standing and not rot away.
Explain these.
Yeah, this isn't huge. This is the size of a hammer here, so that's maybe 5 foot or something.
We've got in Namibia, what's the pristine word?
Fossilized.
We've got also fossilized forest.
Yeah.
Mm-hmm.
Yeah.
In Namibia.
Yeah, there's petrified forests all over the place, all over the world, and that's another system, another way of making them. But the fossils are out there. You can go and search. This is just a quick overview. So soft tissue has been found in dinosaur bones. So dinosaur bones, 65 million years minimum. This was T-Rex. So they were looking at T-Rex. It's a woman called Mary Schweitzer in 2005. She didn't want to rock the boat, but she did. She eventually published, and then she published again in 2009. And there's other people looking into it because, of course, it's very confusing. That there would be elastic, stretchy collagen inside bones. So that again, there's videos you can watch online about that, and of the actual microscope moving the. I could probably find it because I'm on the Wi-Fi, but I can always look at that later. So that's another thing that the only explanation from standard science is that maybe some biofilms or some sort of bacterial contamination that they're finding proteins and finding soft tissue. But it is there, and it shouldn't last that long, of course. Massive fossil graveyards are all over the world, so I like to go and hunt for fossils in Whitby, just a couple of hours south. The south coast of England is a fossil graveyard of chalk. First of all the crustaceans, the White Cliffs of Dover, that's all crustaceans that are laid down in one massive 100-metre high, or maybe 50-metre high cliff. But there's also like these titanosaurs, so that's the biggest dinosaur they've ever found. The titanosaur is like a sauropod, and that's its leg bones are 6 foot for half of its leg. They're absolutely massive sauropods. And this is belemnites, which is more like what you can find at Whitby, which are like squid. So you find a lot more of the marine big deposition than you do of the like dinosaurs, but you do find them, and they're all over. I was just saw in South Africa there's an 8-kilometre thick layer that's uninterrupted, which is which would be interesting. I was going to ask Scott about it, but he's not here.
Where in South Africa?
In South Africa.
Where?
It's the Karoo. The
Karoo.
Karoo supergroup. Like there's a band of rock. That another thing you can look at. There's
massive sedimentary rock in South
Yeah.
Africa. I visited down in Cape Town.
and all over the world. Again, that's it. I'm more focused on the fossils, but the actual geology of the sandstone, the limestone, the chalk, all of these things are laid down in huge amounts all over the world. In Whitby, like you can see with some of these fossils that I've got, that they're washed together. Like you can see that the water has been actually impacting the deposition, and people often talk about how there's one ammonite has been washed like inside another one, or there's wood that's washed up against the side of an ammonite, and you can see that they're not all laid down flat, like gradual, gentle. Some of them are tilted up and all sorts of things. There's marine sediment on the mountains. I haven't got a slide for that, but yeah, and there's trilobites, which are supposedly 500 million years ago, up on the top of the mountains, up in the Himalayas, near Everest, and they were probably laid down and then later on pushed up by all of the plates still moving at the time at the end of the flood. The plates continue to move and push up these big mountains, like there's the Andes, which is alongside a plate, and also the Himalayas. Trackways and trace fossils is another type of fossil, which is basically
Very
fossils.
newsworthy this last few weeks.
Yeah, there was
So-
loads found in England recently, where a guy and a digger hit a bump and then started
Across the quarry floor.
across a quarry, and then found a whole row of footprints, like a walking along, a bit like this, but they're inverted the other way. I think they're standing proud rather than going under, because sometimes they do that. So often these tracks, the footprints are often before they find the animals. So again, if you're looking at that by millions of years, you could say these footprints of this theropod, like a T-Rex, are a few million years before you actually find the bones of the T-Rex. So, which doesn't make sense necessarily in a conventional way of thinking, but if it's in a flood where the water is starting to come in, the animals are fleeing, the footprints get washed and preserved first, and then later on the water catches up with all the animals. Because how would you preserve your footprint? That's what I was going to say as well. If you were going to do it, how would you preserve your footprint?
Frozen nitrogen sprayed on like a clay imprint or something like that. That way it hardens and preserves my footprint.
So clay, good. So like, is that hard or soft or dry or wet?
Well, it hardens when it's.
But when you're doing the footprint.
But no, it'll be soft.
It'll be soft, exactly. So you have to have soft sediments, really. Like a dry sand, if it's part of a desert, you can't get footprints. It doesn't leave a mark that's discernible as a footprint. But some of these footprints are, there's in here. Some of the footprints are incredibly like obvious, or there's lots with reptiles, but you can see the toes, are like the toes going into the sediment, so like the actual claws. And this is one of the world's biggest, which is sauropods, which this is actually now a cliff because it's been inverted by continued pushing. And that's a person there. So it's 5 foot tall, and that's a sauropod. I know, exactly. So it's been pushed right up. But that's like a sort of a clay or something that they've walked on, and they think it's two sauropods with a young one walking along, but probably wading or walking through water to create that muddy water. And then even to preserve a footprint is incredibly hard. Like you'd have to use concrete or clay, and you'd have to use quite a specific process to make it work. And it's just incredible the amount of fossils out there. Here's some other incredible fossils. This top right, does anyone want to guess what these are?
Jellyfish.
Jellyfish. Yeah, who said jellyfish? That's jellyfish. So, again, how would you preserve a jellyfish? That's quite hard to like preserve an impression. That's not the actual fossil, it is an impression, but because they're so soft-bodied that they're just jelly.
Yeah, they're 98% water, so that's quite hard to preserve.
Exactly. So you need a special set of circumstances and not a slow millions of years burial to preserve something like a jellyfish. And so these are the bottom two. Who knows what they are?
Ammonites? Or
No.
Looks like Christmas dinner, the right one.
This is, the preservation's amazing.
Snails.
Getting closer. Nearly like a woodlouse, but yeah, it lives under the sea.
sea
No.
cucumbers, sea slugs?
So trilobite. Anyone heard of a trilobite? Anyone who knows about fossils knows about trilobites. But basically, trilobites are like a bit like woodlice, but they lived under the sea. They're arthropods, and there's so much on trilobites, how incredibly amazing they are. Their eye was incredibly developed and complex, and the detail on some of the fossils is insane as well. And these ones are curled up, and you know that a woodlice, if you scare it, curls up. So there's so many that are curled up in like a defensive position. There's even fossils of where you can see that the trilobite's been digging its way like through the sediment to try and escape, and then just suddenly stops and is dead because they've actually been trying to escape being buried very fast. So like those are really cool ones. And so the Cambrian explosion, I don't know if anyone's heard of that, but this is apparently 500 million years ago. Fossils just appear, so life just appears very quickly, and it's extremely complex, like these trilobites. So that's, the Cambrian explosion, complex straight away, there's no evolutionary sort of change. And Archaeopteryx as well, for years and years has been seen as a transitional fossil. But the more and more I look at it, even scientists now are coming away from that because there's never been any other transitional links found. And it's most definitely a bird. It's not a transition between a lizard and a bird. When you look at all the features, like its perching feet, and the feathers are exactly the same as bird feathers. So there's lots of things. Again, you can look into it more. Amber is one that I've got interested in recently, because it's just the preservation is insanely amazing. So like some sort of earwig and a wasp there. The insects are in pristine condition. There's often bubbles inside them, like this, and also sometimes water inside, which probably it says that it's been quite a high energy sort of environment that's made the sap. So it has So it's not sap. Sorry, it's resin. So resin happens after a tree is injured, basically, or damaged on the bark, and then it releases the resin as a defense mechanism, like blood, to clot, to heal up. So again, the massive amount of this resin that's found in the Baltic Sea and in Burma, there's huge deposits, and it's washing out all the time of the seas, and they're digging it up, and selling it and things. and there's wasps, ants. They find moths, spiders. They've even found snails. They've found a salamander. They found lizards, and they've found feathers inside the amber.
What sort of age? What sort of age are these? Are we aging?
I'm not sure, but it's on the younger end. It's more like, I think it's more like 50 to 60 million years. Just young. But so the mechanism for this in the flood could be that all the trees, as they're ripped off, they're damaged. They are going to be weeping out lots of resin because they've been absolutely smashed by a flood, and all the logs rolling around together and smashing together. You could end up with almost like a slick, or a large slick of this amber, or it would have been resin at that point. Resin floating on the surface or in big globules, which is then trapping insects. Which are the insects would all be in the air, trying to escape or trying to find something to land on, and getting caught up in this resin. And then the resin needs to be rapidly buried, otherwise the resin doesn't fossilize. So if the resin was just left at the surface, just like it would just decay away and rot a bit like an animal would. So all these things require quick burial, which you get with a global flood. I've got some more fossils, but I'll just go into this. Does anyone think they can name any of these?
Nautilus, the top right.
Yeah, okay, we've got one. Nautilus is top right.
Ginkgo biloba.
Ginkgo, yes.
Ginkgo.
Exactly. Ginkgo.
Ginkgo.
Yeah. So that's good. That's a ginkgo tree. So that's
So
common.
they still around today?
Yeah.
Is it a coelacanth?
That's a coelacanth, yeah. That's off South Africa as well.
Mm-hmm.
Found in
Weren't they the ones they thought was extinct? And
Yeah.
turns out they're not extinct.
1938 they found
Yeah.
one. So they thought they're extinct, and they thought they're from, what have we got here? Oh, I've not written down how many million years it was, but they thought it was millions of years. Then suddenly somebody dredged one up with a net off the coast of South Africa in 1938. So these are living fossils. These are fossils that never changed since the fossil record, since the first one. So 500 million years, the Nautilus apparently. So it's not changed for 500 million years. So that's no evolution for 500 million years. The coelacanth is the same. This is a horseshoe crab, which is very common, both in the fossil record and now. The Tuatara, 200 million years, is a lizard. It's like a special, it's a specific lizard which hasn't changed since the fossil record, and same with the ginkgo tree that still grows in Australia like today, and that was 270 million years it was in the fossil record. Yeah, and so it's just open for questions really. There's lots to look at. We can look at these fossils that I brought as well. There's stories behind some of them, in the way they're deposited, and I'll show you one or two here. So I haven't actually more off the top of my head, but so this is a cannonball nodule, which you can find on the beach. They're quite rare, but
Flintstones football.
exactly, they're heavy. So these are found wedged in the cliffs in Whitby. So in Whitby you've got shale, which is quite soft,
Soft shell.
and then you've got these really hard, like precipitated limestone nodules, which seem to have precipitated out of a sort of liquidy environment into nodules which are incredibly rounded, because of the liquid nature of laying down. And I don't fully understand how they're formed, but I don't think common geology would also have a good explanation. But then inside you can find ammonites which are embedded. So usually they crystallize around a biological source. So it can be an ammonite like this, or it can be just a little patch of fish scales. So you can get scales. You can get a vertebrae of an animal inside. You can get coprolite, which is very common, which is a fish poo. So again, even to think about
A bit
that.
disappointing when you find it.
Yeah, you can't go, oh, it's only a poo. It's not a pearl. Yeah. So
You must be surprised by whales being beached.
it's so it's just fascinating how these things are formed, because that can't form slowly. You know, it's very difficult.
It's got to be meters of mud.
Yeah, exactly.
The mud has got
Because this requires pressure as well as, you know, which comes from depth of volume of sediment on top. And just to preserve, and the other one, I've got another one of these, which is still got oil leaking out of the squid. So this is an ammonite, which is a squid, would have its squid tentacles like out of this. But the other one I've got is still like leaking oil from the body chamber,
That's crazy.
and like
Like
it's
from 65 billion years ago.
and
It's
you
quite
can even
impressive.
smell. It smells like oil or like petrol.
That's
And sometimes when you crack them open, like when you're at the coast, you can smell it all coming off the cliffs, like the smell of the methane, not the methane, the petrochemicals, basically, the fossil fuels.
The carbon that you've been releasing.
So, and this is another one, which is just a simple bivalve shell. So it's a shell with two halves, which link together like that. So if you're ever found on the beach, if you go cockle hunting, or you know, to get some for your dinner, you dig up full shells, and they've got the live cockle inside.
Yeah.
Cockles and mussels, they're bivalves. When they die, they fall apart. So if these were all dead animals, they would be in half shells everywhere. But actually what you find is loads of these in full shells. So that's been fossilized as a live creature. It's not at the time for it to die and for the shell to break open. So yeah, there's just loads of different indicators towards how fossils show that, you know, a global flood is the best explanation. So, and that's what brings faith to me, and I love looking at fossils, researching fossils. And every time there's a new fossil discovery, it's really interesting for me to read it, and then be like, okay, let's see what assumptions they've made and how they're going to play their story in terms of how many million years ago it was, and then there's often a very simple explanation from a creationist perspective, which makes a lot more sense, and it's a lot easier to believe actually, rather than believing in all these millions of years. So yeah, any questions? There's loads of fossils we can look at. Some more ammonites. This is a crushed deathbed of hundreds of ammonites all together in one blob. You know, they're all squashed together. There's loads of crushing and squashing which goes on. Fossilized wood, which is found. This is a sandstone block actually, but it's found just like right next to all the ammonites. You know, so wood's been brought into the sea with the ammonites.
So are you one of the weird guys that's picking up a rock and see something in it?
Yeah?
Oh, yeah.
Always, yeah.
Very weird.
So you found these all yourself, Matt?
Yeah, that's like more like a multi-block, I would call it, which is just multiple ammonites.
So these
all
fossil
laid down together.
graveyards, it's really interesting because water, I would say water is a great sort of a sea.
Yeah, that's true.
We have a flood on the farm,
There's that one.
everything's sorted. We get large stones together, and we get the fine stone, we get the sand over here, we get the twigs over here. And this is the thing about the flood, is that we find the earth, everything has been sorted again. We've got these fine sediments that we've got in the Grand Canyon, miles of stuff that we were talking last week about, you know, it stretches for thousands of miles, the sediments in North America, okay? Absolutely pure, they're not contaminated by bio, you know, there's no earthworm tracks, there's no
soil.
grass, there's no soil. When I get a flood on the farm, you go there the next day and there's an inch of sand laying on the top of the grass, okay? Within 2 weeks, the grass is through the sand and it's turned into soil, okay? So it's got to be, sedimentation on this sort of scale has got to be caused by something huge. It's not small floods that's causing it. And again, the sorting mechanism, this is for creation geologists, the sorting mechanism is what allows things like coal deposits. The model for coal, for instance, is that the trees, so somewhere the size of Scotland was a wood, and at the end of the flood, the whole lot was ripped off. So you've got trees, thousands and millions of tons of trees, all floating in an island on the sea surface, getting bashed about, and a lot of coal is formed from bark. And they believe that these logs were just rolling, and the bark was just falling like a complete stream. And this is where coal seams. So the log mat was somewhere. It was dropping all this bark debris onto the sea floor, and then it moved away. And the water is filthy, and then there is a foot of sediment goes over the top. Then the log mass moves back across, and they get another foot of coal put down, and you get another foot of soil put on top. This is how we get the coal seams in Durham and the likes, which are only, my grandfathers both worked in mining, and there were drift miners into these sort of pits, and they were digging seams a foot deep and working, and there was hard rock above and below. Again, limestone, cliffs of Dover, great limestone deposits. How do we get these without a big water event, bringing millions of tons of shells, because they're all the same weight, and depositing them all together and creating limestone, pure limestone areas. So we've got coal getting formed, we've got limestone getting formed, we've got this great sediment all over the earth, big sedimentary thing. Get a nice Jed sandstone. Jedburgh is famous. Huffington is disconformity that he saw in it, but it's also wonderful building stone, and it's pure and it's clean, and you cut it out in blocks and build with it. And you've got oil. Again, we've got under the flood. The flood geologists would say that a lot of the tectonic movements, when they're Pangea, the Bible speaks that the land was one land mass and it broke up under the flood, and that in that 1 year, the whole of the Earth's surface changed, and there was parts of the crust went underneath, a new ocean floor broke up as well, the ocean floor, and there was new volcanic stuff came to the surface, there was new floors created, and when some of this went underneath, these great volumes of water that trapped under the earth happened during the flood. It got trapped, and it's full of biological stuff that came from the earth, and it was trapped underneath, and then it sediments out, the biology sediments out, and you get your oil floating on the water within this great big dome, and we're drilling down and getting the oil out, and putting the carbon back into the atmosphere where it came from. So again, it's another question about global warming. It all came from the atmosphere to start with, okay? And it's all going back there at the minute, which is, it's harming our planet, it's making the planet very different.
It's making it warmer.
Yeah. So for me, one of the things, the fossilization is not, there is no linking these fossils. We talk about the Cambrian explosion, and there's nothing changing. We've got these living fossils. There's so many creatures. I've got an Islamic book. Islam believes in creation also. I've got an Islamic book written by an Islamist it's just packed. I should have had it here tonight.
It's as thick as your
with colour photographs of creatures that are in the fossil record, and they're here today exactly the same. They have not changed in 500 million years or longer, some of them. Okay? So what a fossil is, what you're holding in your hand, is evidence of God's judgment on this earth. That is evidence, not of evolution, but that God is in charge, and He has judged this earth already once, and He said He's going to do it again. Okay, so that's a harsh thing, but that is what I believe, and what creation scientists would say. We don't have to fear because He's a good God. And He sent the rainbow. That is a promise that it's not going to happen by water again. And anyway, we touched on some of this stuff last week. But anyway, that's fossils.
Matt,
More questions?
Yeah.
did you see this one say here, made in China?
Maybe it was.
There's a lot of good fossils in China.
Maybe it
Yeah,
wasn't as much there,
Exactly, that's what I mean.
Not ineffective.
Maybe we were all closer than we think to start with, and we've all been jumping up. Who knows?
Is there certain parts of the world that have like specific types of fossils more than other parts? Is there like, or is it an even spread throughout the world?
I don't know an exact answer to that question, but basically,
Could be sedimentary rock, so
yeah, it's there are similar things all over. That because of the uniqueness of finding different dinosaurs. It's when you get to vertebrates, like how they are, such a small amount of the fossil record. I just found a picture of coal. Like there's a coal seam. We can talk about that later. But you see how real narrow it is, really, compared to the whole one. But yeah, fossils generally, there are generally fossils everywhere. They're of some sort. So there are fossils everywhere. In Antarctica as well, there's that we haven't found yet. And there's a fascinating one actually in, I think it was not Antarctica, but very, very south of Argentina or Chile, right way down, where there's been like glaciers receding, and then they're finding fossils underneath where the glaciers have been. And as the glacier goes back, they're finding them. But there's fossils in every continent, yeah. And they're all slightly different, but they're all there, yeah.
the question I would ask is, where are the fossils that are 10,000 years old? Where are they? There's no fossil. There's no fossil. The youngest fossil they have is like it's 100,000 years old. It's 1 million years old. Where are the fossils at 10,000 years? Why are we not finding creatures that are, whether I say we believe that fossils can form very rapidly. It's been shown in the lab conditions you can create a fossil very rapidly with the right pressure and temperature and chemistry. But where are the ones that are forming? When we had things like the Tsami in Japan, there was 6 foot of mud and sludge came. The fish that were at the bottom of that sludge just rotted.
Yeah.
Okay. So that was a big event by our standards.
Yeah.
And this is the uniformitarianism, which is the great word that they use. That what we see today is what always happened, and it's slow, and that's allowed biology for evolution to happen. Nothing catastrophic happened on this earth, and life has just gradually evolved into us human beings. Anyway, that's. Where are the fossils? 10,000. Where are the fossils that are 100 years old? Where are they?
Yeah, if the process is
They're not forming.
should still be happening.
What else were you saying?
It was basically saying that fossilization can happen very quickly or obviously longer, but a lot of it has to do with the composition of the minerals that are around about the actual whatever's been fossilized.
Yeah, it's called permineralization, when the water in the sediment and not the chemicals, the minerals, which go into the water and then basically replaces the bones or the soft tissue, and replaces it with mineralized water, which turns into stone, basically. So these aren't actual, these are stone replacements of the ammonite thing. But there are different ways of fossilization as well.
So you need that and pressure, is that how fossils are formed?
Yeah, usually. There's also some really cool fossil fish up there.
Anaerobic conditions.
Anaerobic conditions is good because those bacteria are, able just to break down the fossils.
What about human fossils and dinosaurs? Well, not dinosaurs, but
I thought something like that.
Fossils. I mean, are there some together? that would be the glaringly obvious question.
Well, no, exactly. So there is a question on that, and actually, I in one of the books, which I'll maybe just give you the book, but basically, it's a possibility. But like say, if you look at the odds of finding any vertebrate fossil at all, are incredibly small.
Do you think human beings were actually
with
the
dinosaurs?
population now is like 8 billion or whatever, but back 4,000 years ago, it probably would have been a lot less. So the chances are even less of finding fossilized humans. And,
Exactly, and again, like they would float, and they would, just like the dinosaurs would. If once they died, they would probably float. It's just harder to get buried. I don't know what the population estimates were. Was it like 1 million or was it less than that?
At what point?
At when Noah got on the ark, was it? It could have been up to 1 million people even at that point.
Yeah,
But
yeah, more than that.
so because that shows how quick people can reproduce. But then also we went back down to 8, and then the population studies show that we're at the right number if we started at 8 from 4,000 years ago.
4,000 years, not
Which is not
50,
Yeah.
50,000
100,000 years. 100,000 years. But, so there's human fossils, like that they find, and they would try and carbon date them to 100,000 years ago. And there's Neanderthals. There's all the different Homo species. We're Homo sapiens, Homo naledi, and all these things. But most of them, there's a fossil there.
A new one found in South Africa last week.
But-
1.2 million.
So the human fossils is not my area of expertise, but it is fascinating as well. And there's a lot of good information out there you can follow up on.
I think there have been fossils found, like dinosaur footprints and human footprints.
Oh yeah, no, that one. I think that's one of the arguments that a lot of creationists don't use anymore. Like so, because
Yeah.
I don't think it's clear cut enough. I think it's called the Paluxy footprints. Paluxy River footprints. But yeah, anyway, there's one podcast to listen to which was about that, and I think a lot of people are not using that as a good argument for creationism anymore, because it looks more like it's footprints of something that's been in a squelchy mud, and as the foots come out, the mud is squelched in a bit, which makes it look like a human footprint. But you know, I mean, it's so hard to tell.
Yeah, but the populations of both dinosaurs and humans was considerably smaller then than what it is today.
How do you know? Well, dinosaurs, yeah, because there's none today.
Yeah, but like if there was say 1 million people at the time prior to the flood, and say there was as many dinosaurs all on one big continent, like it still is quite a diverse population in grand scheme of things, so they could easily have coexisted at the same time, but just like very scattered out with minimal conflict.
So probably
72 million in.
It could have been 1 million people. It could have been 200 million dinosaurs.
Like we just know so much we don't
the
know.
levels of dinosaurs could have been way higher. And also, like you say, people could have lived in different ecological zones than dinosaurs, so they wouldn't necessarily cross paths every day. You know, humans would be stupid if they want to live next to T-Rex. They would be
like if we found a T-Rex
up on
with
the
a
hills,
human
out the way.
skeleton in its belly or something like that, that'd be pretty convincing evidence they coexisted.
Yeah, no, exactly. One day, you never know. But I think God doesn't even though God's given us a lot of super obvious stuff,
Yeah, there's also
even people would still manage to find a way to doubt it because they're willfully blind or being indoctrinated in a different way.
But
It's
they
a different worldview.
They
This,
always try
obviously.
and make an excuse, don't they?
Exactly.
They always try to adjust the evidence to their theory rather than...
Absolutely.
Yeah, so how
But-
did they actually come to the conclusion that the world is so old? I mean,
Exactly.
yeah, how did they create this?
Biologists. It
Yeah.
comes from biology.
Well, sort of.
It comes from geologists first, really.
No, but I think a lot of it, especially to do with carbon dating, I think it's carbon dating, is to do with the layering. And obviously, in our modern time, those sort of layers would take millions of years to make.
If you
So
did
they're
today's
assuming-
conditions,
Yeah, in today's
and
condition,
then
that
run it
would
backwards.
take, but they're not
Yeah.
incorporating an event such as the flood or some other sort of mass event that could do that.
Yeah. Another interesting thing is sedimentary rock. So most of the rock in the world cannot be dated by radiometric dating, which Dad's going to touch on. But so they have to do it by is it the igneous or metamorphic, or can they do both? I don't know. The rocks that are changed by heat, like the metamorphic rocks, and the igneous rocks, which are literally the igneous rocks, it will be the date,
There's
which
no
comes straight.
guaranteed method.
No, exactly.
I'll be speaking to that.
No, but they try and date the igneous rocks, which are coming from lava. So the lava, they try and date the lava rocks, and then they try and say, okay, well, we think there's a lava rock here, which is 350 million years, and then this layer of sedimentary rocks on top of it, so it must be that age. So they just say it must be that age, because we think that by the radiometric dating that is that age. But you'll see with radiometric dating, there's lots of problems with that. So it's all guessing.
When we're on that,
really.
it's not a point I'm going to make particularly, but
Yeah.
that's exactly what they do, is they take a rock
Yeah.
They say of known age.
So they say
And
we
then this
know
one's
this
above,
this
so
lava
this is younger,
is
of
200
known
million.
age, but really
So
they
then
have no.
these ones must be younger on top.
Yeah.
It must be older underneath.
What was the name of the island that was created by a...
Surtsey.
Sorry?
Surtsey.
Yeah, and
Blew out the
didn't they
water.
take some carbon date from that? And they said it was
I
so
don't
many
know. Yeah.
millions of years old, but it was only like 10 years old or something.
Oh,
like that.
Mount St
it.
Helens, some of the
Mount St.
stuff was
Helens is some
dated
of the
there
best stuff,
5 years later.
They've done an island on Hawaii as
millions
well.
of years, yeah.
Proves
And then
it
Mount
just
St
doesn't
Helens had the
work.
trees as well, didn't they, in Spirit Lake? The trees
Yeah, that's right.
that sank into the lake really quickly.
Just like this
standing up.
coal beds and polystrate
But-
fossils.
and yet there's still some there. There's still a log map on Spirit Lake.
Yeah. There's,
But a lot of them at some point get waterlogged and go vertical, which kind of explains why you get these vertical trunks. They just
because the root ball gets inundated with water and gets heavier, and then suddenly they go down to the bottom. So then they stand like that as the other layers quickly build up all around them, and they become polystrate, just like that.
Yeah.
I'm sure
There's a guy in creation scientist in Australia. You're going to remind me of the name. Who's done experiments?
Mackay,
John Mackay, that's one. Who's done experiments, and you can see it. He's videoed it, sort of, just with wee twigs.
Yeah, he
so
does
that
it with like
happens,
matchsticks. You can do like a little experiment
lot
with
quicker, and you
matchsticks
have
to see
some
how they
floating on
sink.
top.
Yeah.
Because it would, because it's even a matchstick knows its grain, so that it will fill in water from the ends. A matchstick doesn't fill in water from the middles; it only goes in the two ends. So the water
And it becomes unstable.
it
So
becomes
the,
unstable and suddenly goes.
the bit which is lower down is under higher pressure, so more water goes into that. So it's it starts at a bit of an angle, and
Yeah.
So that's he's a big part of creation research, which I really am interested in as well, because Creation Research UK have a little museum in Oswestry down in England, and which they've just opened in the last 3 or 4 years.
Wales, I think.
Wales.
Oh yeah, Oswestry
Yeah.
is over the border. Yeah, it's in Wales, but it's on the border. Yeah, so they're doing this creation research all the time, and on a bigger scale than matchsticks in water, but little things like that can actually be.
Making coal in weeks.
Yeah, so the ginkgo leaves, they're using those actual ginkgo leaves in Australia, sorry, and then putting them in poly pockets with different levels of clay and enzymes and things to make a reaction happen chemically, and trying to create coal quickly, and they're able to do it. I haven't looked at the whole details, but they're able to do it like quite quickly, between 3 and 8 weeks of time, and that's without having. I don't think that's having pressure either.
No.
I don't think they're pressurizing. It's just a bag, a Ziploc bag with
And
chemistry.
coal is the hardest one.
Is it?
Yeah.
Not as hard as
I mean,
diamonds.
there's a geologist I saw a video online of, and as he did his degree,
Yeah.
they would make different sorts of rocks under pressure, and most of them were made within hours.
Yeah.
Coal's the hard one. That takes weeks,
Yeah. Very hard.
but not years.
Not millions of years.
So
Not
all
hundreds of millions. Of years.
this fossils that you found,
Yeah.
where is it just in the UK or?
I should. Yeah. No. So all over. So there's fossils in Skye.
The ones you found.
The one, sorry, yeah,
Yeah.
in the UK, yeah, but I'm hope to go fossil hunting in South Africa maybe. There's But there
I
is
was
fossils
going
everywhere.
to look it up, but actually, if the one thing which we do is kind of get you searching. You've been searching on some stuff as you were saying earlier, if that question comes to your mind,
yeah.
I mean, I'm typing in world distribution fossil. Click on images. It's not coming up because it's not communicating. But you'll see that, and some interesting patterns. I've had a look at that before. So things like west side of South America, the Atacama Desert, which was famous for those miners who got trapped. There's lots of whales, a whole load, 1,000 feet up on the continent. There's massive dinosaur fossil beds, and in some places they're all smashed up. In other places they're a bit more laid out. But you can start to sort of piece together what's happening. You can look at, there's some geologists who've looked at, you can see with the sedimentary rock where the water was flowing when it was laid down. But it was flowing in different directions at different times. You can actually even look at the local geology, and you can tell that the west side and the east side of the hills across the borders. Just look at the topological map and the grid lines, not the grid lines, the contour lines, and you'll see which direction the last flow was, because one side is steeper than the other, and it's consistent. You know, you look around all around the borders,
Well,
and you can sort
but
of
the
see
borders has been
things like
affected
that.
by ice a lot.
That
By glaciation.
becomes.
Glaciation post flood. But yeah, but the sedimentary rock underneath is laid down, but it's been carved away. This is a little. I just literally did what James said, and this shows how, you know, there could have been. This is not a creationist model, but this is just showing how there's similar fossils found in those different areas of Africa and South America, and between where, you know, they could have linked up.
This is them with their, you know, with the continents together as one thing before it broke.
Which this could have been what it looked like when, you know, before God decided to flood the earth, and then all the continents moved apart. And James talked about that, the crease lines in the sea, which we can see that have been pulled, and there's the mid-Atlantic ridge, which is pulling apart, where the continents have moved apart and things.
So what is the green line there?
It says fossils of the fern Glossopteris found in all the southern continents show that the continents were once joined. Which it doesn't necessarily, because I think God's flood could have deposited things all over, you know.
It is interesting that, like, I guess you have to have a big paradigm shift, one timescale wise, from, is it 50 million?
What?
For the deep
4.5 billion.
4.5 billion is deep time.
13.8 billion.
And like 10,000 years is a biblical model, is it?
Yeah, but within 100,000, I would say.
But I guess like it's like you have to have faith to believe that God was so powerful that He did it all super quickly, and like it's catastrophic in like a huge way. As soon as you were asking the question, how did geologists ever think that it was really old? Well, like James Hutton was looking at the rocks. He was looking at the rocks and being like, how on earth do we get rocks like this and rocks like this?
Yeah.
Maybe that it took billions of years for them to slowly go back under the crust and back over.
Can you just leave it on that for just a moment?
Yeah. But like the alternative is you have to have enough faith to say God was so powerful that He smashed crust together somehow, and it ended up like that. I don't know.
Yeah.
I can't
Well,
tell you more detail than
if He created the Earth, and it is so fragile. We're hearing that you know it's like the Mount Everest is the Earth is smoother than a billiard ball in relative to its size.
That last week.
If we expanded up a billiard ball to the size of the Earth, it would have mountains on it higher than Everest. So the Earth is smooth. Okay, it's also fragile. We've got a crust. We're talking that James talking crust.
Very thin
it's very
crust.
fragile. You know, it's amazing. We're living on this fragile. We're living on this ball of molten magma, and you know, it's not that thick. Relative, it's 10,000 miles across, and if the crust is less than 100k, so we've got 100k either side. We've got 9,800 kilometres of goo, bubbling, hot, horrible stuff. And if the gravity, I say we were talking about densities last week about things falling and whatnot. If God, the Bible says in Genesis, God called the land out of the sea. Okay, so that was the Pangea. And then He said, during the flood, it was inundated, everything was covered by water, and He again called the land out of the sea, called the mountains back out of the sea. The Bible spells it out, and it's like, why is it there? It's unbelievable.
How did Moses make this up? It was inspired by God,
it's inspired, and it's just true to what we see, and the continents, the creation model would be that most creation models would be that the continents, the Pangaea broke up under the flood. There was bits went underneath the sea floor, so that the land broke, the sea floor would be thinner, and it broke, and bits went underneath, other bits came to the surface. It was a completely new thing, but that Pangaea broke up and it's still visible today. We're not arguing that it looks like it all fitted together as one, but there's mechanisms where it can travel really quickly. I mean, fast,
meters per second.
Hundreds of miles an hour. It's
well,
traveling.
The
crust is moving at
10
rapid
miles an hour,
speed,
which is fast enough.
Underneath other bits, creating great heat, and there's volcanism. The whole Earth is in a right mess. But the ark is sitting on the surface, and we have to believe God is protecting that life. There's reasons why the flood happened. It was judgment, and we're not going into that. We'll try to touch on a few things on that last week. And there's reasons why God called it to an end and wanted stability. There's reasons, I believe, for things like why the coal and oil reserves were put there, so that the population of this planet could be what it is today. Because otherwise it couldn't be.
We'd just be burning
without
the trees, and there'd be no trees
left.
left.
It also gives us confidence that God knows what's happening. He's not concerned about global warming. He sucked all that carbon out of the atmosphere. We talk about carbon later. But anyway, there are some amazing signs that God has put in there.
And there's a fossil book there, which is incredible. Loads of fossils, and there's loads of other material. Books through there.
Loads of resources through there. Anyway, it's coffee time now. Lou, stop. And we're doing dating.
Can I just ask one quick
question?
You were talking about a podcast or something.
Yeah.
To what?
Multiple.
What was that? Which ones do you think are good?
So the Creation Research UK have a weekly Friday night stream on YouTube, but they also put onto a podcast on Spotify. Let's Talk Creation is quite deep, but it's also very good. If you want one topic, they've done 150 podcasts on lots of different subjects.
Answers in Genesis. That's quite good.
Answers in Genesis is good. Like some have different models, different flood models, and I don't know. I can only speak for the ones I listen to and I trust. I don't listen to Genesis 1, so I don't know what it's like.
It covers a whole lot of different things.
Yeah, exactly. Well, that's it. But it covers everything from archaeology, of recent times, biology, physics, chemistry, space.
There's a series and a film, Is Genesis History?
Is Genesis History?
I would
very
recommend. That's on YouTube.
Yeah, so if you want to go deeper, so the overall film is now free. If you want to go deeper, you can. There's like 3 segments. There's rocks and fossils, and there's another like 5 or 6 or 7 videos of all about 20 minutes each, going into more detail on just the rocks and fossils, more detail on just the stars and the planets, and then the biology one and the humans and archaeology and how apes didn't evolve into humans and were completely different, and all these things.
I'll just give you the sort of overview of the creation organisations as far as I understand them. There's the Creation Research, which is basically Mackay and John Mackay in Australia, and
they do the Creation magazine.
Indiana Joe in Wales, and they do a bit of research. They're quite a small organisation. There's Answers in Genesis. Their take is quite a theological. So for Christians who say the Bible is true, therefore, that's an okay start. I wouldn't point a non-Christian at that, because they say, well, the Bible says, therefore, and a non-Christian's kind of going to go, yeah, but the Bible's a load of nonsense. So that doesn't help. Creation Ministries, which is also based in Australia, at creation.com is where I would point most people to, and they've got brilliant articles and you can search. So if you've got a particular question, I would go to creation.com, type in your question.
Yeah, that's a good start point.
And
they've got the magazine as well.
Is Genesis History is a brilliant load of work which folks have done on for geology.
And that's more exactly coming at it from the world and saying, what do the rocks tell us? What do the fossils tell us? And then going, oh look, it matches up with what the Bible says. So and it's brilliant. And then also using the Bible to give us clues. What should we find in the rocks? What should we find? And then they're making discoveries because they're coming at it from a different paradigm. And they can actually make progress where other scientists are stuck.
I was saying this to Jan and James the other day.
It's almost like they have the right puzzle pieces,
they're just putting them together wrong.
Yeah. That's probably one way of looking at it. Yeah.
I mean, that picture up there I think is great, because one of the things it shows is you get the same fossils on different continents, although they're now separated a long way, which kind of flies in the face of the sort of it was only in Australia where kangaroos evolved, because the reality is you get them all over the place. What is interesting is that picture will show you all sorts of images of things which they think are old. They've cherry-picked those. You can actually do that with almost every animal, and I've seen a guy do that, and they've found fossils across these different places, and they are linked across the way, but not across the continent, across the ocean segment. So
you said that, like this is linked here,
yeah,
but it's not linked here.
Yes.
Like it's not linked here and here. Like if you got these fossils here, it should also be here because there's no barrier.
But they've deliberately cherry-picked. Those are all images of things which are extinct, but are precursors to the hippopotamus and precursors to the crocodile, etc. And so there's a sort of storytelling there.
Yeah.
You could have done that with any number of animals, including ones which are extant, which are still around.
Yeah. Yeah. So if you want a free fossil as well, free fossils to take.